Xin chào các bạn, mình là Phút đọc sách. Hôm nay mình sẽ đọc truyện của What If. Relativistic baseball. Question: What would happen if we tried to hit a baseball pitch at 90% the speed of light? The answer turns out to be a lot of things, and they all happen very quickly, and it doesn't end well for the batter or the pitcher. I sat down with some physics books, with a Nolan Ryan action figure, and a bunch of videotapes of nuclear tests and tried to sort it all out. What follows is my best guess at a nanosecond by nanosecond portrait. The ball would be going so fast that everything else would be practically stationary. Even the molecules in the air would stand still. Air molecules would vibrate back and forth at a few hundred miles per hour, but the ball would be moving through them at 600 million miles per hour. This means that as far as the ball is concerned, they would just be hanging there, frozen. The ideas of aerodynamics would then apply there. Normally, the air would flow around anything moving through it, but the air molecules in front of this ball wouldn't have time to be jostled around the way. The ball would smack them so hard that the atoms on the air molecules would actually fuse with the atoms in the ball's surface. Each collision would release a burst of gamma rays and scattered particles. These gamma rays and debris would expand outward in a bubble centered on pitcher's mound. They would start to tear apart the molecules in the air, ripping the electrons in the nucleus and turning the air in the stadium into an expanding bubble of incandescent plasma. The wall of this bubble would approach the batter at about the speed of light, or slightly ahead of the ball itself. The constant fusion at the front of the ball would push back on it, slowing it down, as if the ball were in a rocket flying tail first while firing its engines. Unfortunately, the ball would be going so fast that even the tremendous force from this outgoing thermonuclear explosion would barely slow it all down. It would, however, start to eat away at the surface, blasting tiny fragments of the ball in all directions. These fragments would be going so fast that when they hit air molecules, they would trigger 2 or 3 more rounds of fusion. After about 70 nanoseconds, the ball would arrive at home plate. The batter wouldn't even see the pitcher let go of the ball, since the light carrying that information would arrive at the same time the ball would. Collisions in the air would have eaten the ball away almost completely, and it would now be a bullet-shaped cloud of expanding plasma, mainly carbon, oxygen, hydrogen, and nitrogen, ramming into the air and triggering more fusion as it went. The shell of X-rays would hit the batter first, and a handful of nanoseconds later the debris cloud would hit. When it reached home plate, the center of the cloud would still be moving at an incredible fraction of the speed of light. It would hit the bat first, but then the batter, plate, the catcher would all be scooped up and carried backward through the backstop as it decontracted. The shell of X-rays and superheated plasma would expand outward and upward, swallowing the backstop, both teams, the stands, and the surrounding neighborhood, all in the first microsecond. Suppose you're watching from a hilltop outside the city. The first thing you would see is a blinding light far outshining the sun. This would gradually fade over the course of a few seconds, and a growing fireball would rise into a mushroom cloud. Then, with a great roar, a blast wave would arrive, tearing up trees and shedding houses. Everything within roughly a mile of a park would be leveled, and a firestorm would engulf the surrounding city. The baseball diamond, now a sizable crater, would be centered a few hundred feet behind the former location of the backstop. Major League Baseball rule suggests in this situation the bat would be considered hit by pitch, and would be eligible to advance to first base. Tôi đã đọc xong phần đọc của tôi. Cảm ơn tất cả các bạn đã lắng nghe.